Okay, year 13s, we've come to our final lesson on trigonometry, which is also, well, kind of the final lesson on trigonometry. There is some differentiation. However, the final lesson in the trig chapter is factor formulae. And so in your notebook, it's going to get you to copy down these 4 formulae here. Then the second, what we're going to do is we're going to prove one of them. So if you make sure that you get those down, and you can obviously pause the video, but then what we're going to do is what we're going to do is we're going to try and prove this one here. So sine p plus sine q equals 2 sine p plus q over 2 cos p minus q over 2. And what we're going to do in the next example is we're going to see how to use the factor formulae, but first of all we're going to just prove them. So we've got sine a plus b, sine a minus b. So it says we're going to use them. So sine of a plus b is sine a cos b plus cos a sine b. And then sine of a minus b equals sine a cos b minus cos a sine b. Now, very often in recent years, edXL have said that you have to prove stuff, and I haven't seen them ask you to prove this. So, what we're going to do is we're going to do sine p plus sine q equals this thing here. So, what we're going to do is we're going to do this one, add this one. So, if we do sine of a plus b, so it's just a matter of trying to memorize this, plus sine a minus b. That's going to be this thing, add this thing. It's going to be sine a cos b plus cos a sine b plus this one. Sine a cos b minus cos a sine b. Now what you notice is that we've got plus cos a sine b minus cos a sine b. So those are just going to cancel. And then we're going to add these two things together. That equals 2 lots of sine a cos b. So that's sine a plus b plus sine of a minus b. Now what we need to do is we need to prove this top one up here. So it's not sine of something plus something, it's just sine of p plus sine of q. So what we're going to do is we're going to replace this with p and we're going to replace this with q. So if we go to the left-hand side of the screen here, so if we're saying that a plus b equals p and a minus b equals q, then we're going to get sine p plus sine q. So that looks like the first bit of this up here. So we're going to make it look like the second bit now. We've got 2 already, so it's going to be 2 sine, but we've got sine a. So we need to work out what a is in terms of p and q. So what we're going to do is we've got this thing here and we've got this thing here. So what happens if we add them together? So a plus b plus a minus b, that equals p plus q. So we've done this thing, add this thing. If we get that, a plus b plus a minus b is going to be 2a. That equals p plus q. So if we then divide by 2, it's going to be a equals p plus q over 2. And here we're going to replace this a with p plus q over 2. So it's going to be sine of p plus q over 2. So it's going to be 2 sine p plus q, and we're going to have cos, and then instead of b, we're going to replace b. So again, what we're going to do up here is we've got a plus b equals p, a minus b equals q. So we're going to do this one minus this one. So we're going to do a plus b minus a plus b equals p minus q. Now just be careful with that, because we've done this thing here minus this thing. When we do minus this one here, it's going to be minus a, then minus b. It's going to be plus b. So if we simplify that, we've got a minus a just goes. B plus b is going to be 2b. So we've got 2b equals p minus q. So b equals p minus q over 2. And then go back to this one here. Instead of cos b, we're going to have cos p minus q over 2. So that's a proof that you can just read through and then learn, and then be able to replicate in case they ask you in any exam. Again, pause it, rewind that bit, go over it a couple of times, make sure you've got it down in your notes. Let's see how to use it. So we've got here, using the result that sine p minus sine q equals this, we've got to find out what this is. So here, what they've done is they've replaced p with 105, they replaced q with 15. So we should know that sine 105 minus sine 15 equals 2 cos, now this is p plus q divided by 2, so that's going to be 105 plus 15 divided by 2, sine 105 minus 15 divided by 2. If we simplify, that's going to be 2 cos 120 over 2, which is 60. So 2 cos 60. A little bit neater. It's going to be 2 cos 60. Sine now 105 take away 15 is going to be 90 divided by 2 is 45. Okay, so then if we multiply that together, 2 cos 60 is a half. 2 times by a half times by root 2 over 2. So 2 times a half is going to cancel out, so we end up with root 2 over 2. Which is an odd question because they don't ever leave a fraction on the bottom, but if we times top and bottom by root 2 there, that's going to be 2 over 2 root 2. 2's cancel out, leaving you with 1 over root 2. So that's how you use it. When you've got it in this format here, so we've got sine of something plus or minus sine of something, or cos of something plus or minus cos of something, and these angles are different, what we can use is the factor formulae, which you've got written down here. Okay, so let's have a look at another question here. We've got to solve for in between 0 and pi, or 0 and 180. Sine something, take away sine of something. So what we've got here is p, what we've got here is q. So if we write that out, sine of 4 theta minus sine 3 theta equals 0. We can replace this with 2 cos p plus q divided by 2. That's going to be 7 theta over 2. Sine p minus q over 2. So sine of 4 theta, take away 3 theta, so that's going to be theta over 2 equals 0. Then what we've got to do is we've got to solve that. So in order to solve this, we've got 2 times by cos of something times by sin of something. So we make this then equal to 0. We have cos of 7 theta over 2 equals 0. And we set this thing equal to 0. So sine of theta over 2 equals 0. So if we've got cos of 7 theta over 2 equals 0, what I'm going to do is I'm going to replace 7 theta over 2 with a, so cos a equals 0. And instead of it being between where theta is between pi and 0, I'm going to multiply that by 7 divided by 2. So a is going to be between 0 and 7 pi over 2. Then if we have a look at the cos graph, that's going to be theta, 2 theta, which is 4 theta over 2. That's fine, yeah, 4 theta over 2. 2. So that's going to be 3 theta, which is 6 theta over 2. And this down here, that's going to be 8 theta over 2, or 4 theta. So this one here is theta over 2. That's theta, so that's 2 theta over 2. This one here is 3 theta over 2. This one here is 5 theta over 2. And this one here is 7 theta over 2. So where cos a equals 0, a equals theta over 2, 3 theta over 2, which is 5 theta over 2, and we've got this one here, which is 7 theta over 2. However, we've then got to replace a with 7 theta over 2. So what we need to do is we need to multiply everything by 2 and divide by 7. So theta equals, so a, no, so theta equals theta over 7. So times by 2 divided by 3 is going to be 3 theta over 7. 5 theta over 7 and theta. That's going to be the solutions for the cos. Then we've got to solve this one. So in exactly the same way, we're going to solve, try that again. Sine of theta over 2 equals 0. So theta is in between pi and 0. Sorry, all of these, just realised that should be pi over 2, not theta over 2. Right, well done if you spotted that, it should be pi, not theta. Okay, so we replace this with an a, so it's going to be sine of a equals 0. And then a, because we're dividing by 2, is going to be between pi over 2 and 0. We have a look at the sine graph. So it's only going between 0 and pi over 2. There's only one solution, which is 0. A equals 0, and we replaced a with theta over 2. So theta, we need to times your answer by 2, so that's still 0. Oh, not theta. So the solutions for that are going to be these ones, and then also theta equals 0. So now let's go and have a look at the next one. And by the way, you can have a look at that. That's in your exercise book, that example, as is this one. So we've got to prove this thing equals tan of x plus y. Now it's kind of tricky to see where to go with this one because there's so much here. However, the first thing I'd do is I'd have a look at this tan of x plus y and realise that that is sine of x plus y over x plus y over cos of x plus y. Now I think this would be a hard question to do if they haven't given you any direction, but here they haven't. So I'm going to try and keep that, and bear in mind that we know it's in the factor formulae section. Let's have a look at the numerator. So I'm going to get that to one side, so let's get rid of this. So numerator. So sine of x plus y plus sine of x plus 2y plus sine x. And what we could do is we could use a factor formula and say that this thing here is p, this thing here is q. So we've got sine of p plus sine of q. Now we know that sine of p plus sine of q equals 2 cos. Oh no, sorry, it's 2 sine, isn't it? 2 sine of p plus q over 2 cos p plus q, p minus q over 2. So let's use that for this thing here. So we start off with the sine of x plus y. We're going to add this thing here. So 2 sine of x plus 2y plus x divided by 2. So x plus x is going to be 2x plus 2y divided by 2 is going to be x plus y. Cos, and it's going to be p minus q over 2. So it's going to be x plus 2y minus x divided by 2, which is going to be cos y. And what we can do, we can see that we've got sine of x plus y here, and we've got sine of x plus y here. Something that you need to do quite often with the quotient rule is see that you've got a common factor in both of them. So if we factorise that out, it's going to be sine of x plus y bracket 1 plus 2 cos y. That's the numerator. And deal with the denominator in exactly the same way. So denominator. So again, because we know that sine of x plus y over cos of x plus y is tan of x plus y, let's bring this thing to the front. So cos of x plus y plus cos of x plus 2y plus cos x. Now we know that cos of p plus cos of q equals 2 cos of p plus q over 2 cos of p minus q over 2. So let's see how that works out. So here we're going to let this thing be p and this thing be q. We've got cos of x plus y plus 2 cos of x plus 2y plus x divided by 2. Again, it's going to be x plus y. And if we do cos of this thing minus this thing divided by 2, it's just going to be cos y. Again, we can see that we've got this thing in both of them. So again, let's factorise that out. So we've got cos of x plus y bracket 1 minus 2 cos y. So this is the numerator, this is the denominator. So once we've done both of those, let's do the numerator over the denominator. And we've got sin of x plus y, 1 plus 2 cos y, over cos of x plus y, 1 plus, sorry, should be plus there, 1 plus 2 cos y. Now what we see is that this cancels out on the top and the bottom, leaving you with sine of x plus y over cos of x plus y, which equals tan of x plus y. I think that's a really, really tricky question, and I certainly don't believe that they'd give you that without giving you any direction. But let's say the worst comes to worst and they do. What you need to do is notice that we've got tan of x plus y here, and we've got part of tan of x plus y. We've got the solution right here, so it means that we need to get rid of this and this. So on the top you've got sine of something plus sine of something. On the bottom you've got cos of something plus cos of something, where those somethings have different angles. So if you've got sine of something plus sine of a different angle, then what we've got to do is we've got to use the exact formula, because this is sine of something plus sine of something, where these two somethings are different angles. So it's just a matter of getting used to knowing when you use these. And it's when you've got either sine and sine or cos and cos, and you're either adding and subtracting, and they're different angles. And that is our final lesson on trig. Okay, so if you want to come to your next lesson with those notes already in your book, and then we'll move on.